What are zero trust SD-WANs? And how do traditional VPNs even work? And why would I need protection if I have a padlock in my browser?
Good morning! Now, that's a great question. Let us start with those padlocks you see. They mean that you're an encrypted connection between you and the website you are visiting. This is also known as HTTPS, with the S meaning secure. While HTTPS protects your information between you and the website, it doesn't exactly hide who you are and where you go. That's like trying to send an envelope. The outside is visible to everyone, like for example the return address, but the inside is scrambled, even when you open it, from whatever location. Now, that's where virtual private networks come in, or short VPNs. They fix these issues with concepts like IPsec and a secure tunnel.
A secret tunnel? That sounds fancy. How does that work?
First, let's break down the terms. We will be working on the IP level of the OSI model, which are like basically the addresses of the internet. We will be adding a layer of security called IPsec. We get close to more traditional consumer VPNs. It's essentially just a set of protocols that encrypts data traveling across a network. Think of it as scrambling your messages, for example, before sending them, in addition to also scrambling your address. It makes all of your internet traffic secure compared to HTTPS, which only protects the info between you and the website. Now, tunneling is a second feature of VPNs, and it takes that encryption a step further. Imagine wrapping your scrambled message in another layer of protection, like putting it in a secure box before sending it through a tunnel. Finally, most VPNs combine these two technologies, IPsec and tunneling, to create a secure connection between your device and a remote server. It's like having your own private internet connection, even on a public network. In a nutshell, a VPN offers an extra layer of privacy by masking your entire online activity.
That sounds impressive. But with so many VPN providers out there, which one do you choose?
Let's take a quick look at some popular options. For example, NordVPN, Surfshock, and PIA. They all offer features like strong encryption, multiple server locations, and the so-called no-logs policies. However, they might differ in pricing, features, and user interface, for example.
The examples you provided all sound like VPNs used by individuals, but isn't there something like enterprise VPNs?
Indeed, enterprise VPNs are where the concept originated. While I'm not well versed in this area, I know someone who is and who is willing to help you.
Hey there, Rahul. I've got a question. What is OpenVPN?
It is essentially an open source virtual private network solution that is very flexible and adjustable to your needs. This is done through encrypting the data and ensuring privacy and anonymity online. It has strong security features like any VPN. And additionally, it's open source, meaning the code is freely available for inspection and auditing, which enhances transparency and trust. And there's also a huge community making networks and sifting through this code. However, like any technology, OpenVPN also has its downsides. One common concern is the potential for slower connection speeds, especially when compared to other VPN protocols. Because of its flexibility, it has a way bigger code base and more options. Setting up and configuring OpenVPN can be a bit complex for beginners, requiring some technical know-how.
So what are some technical use cases for OpenVPN?
The idea is called deperimeterization. And let's start with something called site-to-site networking. For example, we have a company like Airport Incorporated. They have 3 airports across the globe and they want to be interconnected. Now, what you could do is set up 3 OpenVPN servers and each airport site and interconnect them via the closest cloud connects to regions. This has a benefit that these sites can now be interconnected, and additionally, users that are telecommuting could also be connected to any of the airports using a secure connection. At the end, we have a wide area private cloud, which is a virtualized network as a service. Considering you are an individual, you probably don't need this sophisticated technology. You could take a look at ZeroTier, which is a zero trust SD-WAN. It solves some of our problems as well. I, however, don't know much about it, but I do know someone that does.
Well, thank you very much, Rahul. I will certainly check that out.
Could you explain to me what a zero trust SD-WAN is? Rahul probably told you about a traditional VPN service like OpenVPN. Now, how does that really work? Let's say you're a client and you want to connect to Bob, who's in the same room. Well, what you have to do is you have to send all your packets to a concentrator. And worst case scenario, that concentrator could be across the country, like 300 miles away. And if Bob and I are in the same room, 300 miles away is a really big round trip time, which is bad for latency, it's bad for throughput, and there's different problems with that. Specifically, like a single point of failure. If the concentrator goes down, you can't communicate anymore. Additionally, using a concentrator like this means that all your packets have to go through that concentrator, which is a very expensive solution. Is it also possible to do this in an inexpensive way? Now, yes, you could do this. For example, you could use something like ZeroTier, which is a software-defined networking architecture, which allows seamless and secure connections between devices. It's regardless of their physical location or network configuration, right? So it's zero configuration, essentially. How does ZeroTier solve this problem? Well, they do this. They make a direct connection between both nodes. Well, first of all, you can already see it. It's way better for latency, it's way better for throughput, because there's no additional hop and no additional distance that needs to be covered. A single point of failure is drastically reduced because they still use root servers to exchange some useful information, but we don't need to constantly send our data through it. And lastly, it's an entire zero trust network because the private keys never leave the nodes themselves. ZeroTier is a peer-to-peer network, right? And let's say that there is a peer A that wants to connect with B. How do they do that? Well, A doesn't know anything about the network, doesn't know who is connected to who, doesn't know anything. The only thing that it does know is that there are something called root servers, or planets in this case. So what happens is A sends something to the planet and says that it wants to communicate with B, right? And then the planet essentially forwards the connection, so it forwards the data. And while they are communicating with each other, both A and B try to make a direct connection through the information of the planet, right? So the planet sends additional information, and then they can make a direct connection. So what I explained right now is the control plane of ZeroTier. And the next thing that we'll be talking about is WireGuard, which is the data plane. It's essentially a protocol. I don't know much about WireGuard, but I do know someone that does.
Hey Tom, I've been learning about VPNs. Could you explain to me how WireGuard works?
Imagine the internet is like a giant highway system. Information travels in packets, zipping from one computer to another. But sometimes you want that information to be private, like a secret message between friends. Think of WireGuard, a VPN, which is a solution to this. It uses a brand new set of instructions, a special codebook to build these tunnels. This codebook is much smaller and simpler than the dusty old ones used by most VPNs. Now, why is that important? Because small codebooks means less congestion, less traffic jams in the tunnel that translate to blazing fast speeds for your internet travel. Now, let's switch to the bad side of WireGuard. There are some problems with WireGuard. For example, it uses the same kind of cars and the same kind of color every single time, which means that it's pretty recognizable for people looking for your packets. This is called obfuscation, which WireGuard does not actually do. The developers assume that there are some sort of implementations at a higher level. Speaking of a higher level, Tailscale is an up-and-coming solution similar to ZeroTier, which uses WireGuard as a data plane and as a control plane, making it a full-fledged solution. But hold on, there is more upsides. WireGuard is also designed to be easier to use. Setting up a VPN can feel like navigating a maze, confusing, full of dead ends. WireGuard cuts through the confusion with a simple handshake. Imagine exchanging secret high fives with the server to get connected, instead of the whole complicated dance. Now, there are some things to keep in mind with WireGuard, right? It's still pretty new, straightforward, easy to use, but it's like a fancy gadget. So it isn't really as battle tested as the older VPNs, for example, OpenVPN.